So, Boudewijn, please, the word is yours.
Thank you, Johan. Yeah, I will try to make it very short. I sent out a questionnaire to everybody to have their input on what they consider is wrong with ready-mix concrete. I received only a few. The one most remarkable was the one that say, I'm not going to tell you because otherwise we only will buy prefab. So, but that was not the answer I needed, okay? Of course, what is wrong, here we have a list. It is, of course, it is owned by, for 50 to 80% by the cement industry. And as somebody said, they consider it packaging of their product. And you can see that when they charge you €4 more if you want a concrete with less cement. And of course, the worst aggregate, more cement is needed. Process control is Labcrete, which is not quality control of the half product, because the structure, of course, is Realcrete. We have 27 different EN206s. So make your choice which sauce you want over that EN206. So this has nothing to do with technology. That is a pure market positioning. The production and the placing is most different by different companies who can blame them each other. And the language of communication is a problem, and there's no basic training, etc. You are welcome to complete this, of course, this list. Next, please. Now, the other one was, where was it? Well, this was a little too fast, Dav. Maybe you can bring it back on the screen. No, the second one. Errors on site. What is wrong? Okay, next. Maybe I messed it up. You just go to the next slide. Errors still till supply on site. Okay, aggregates are not conform but still used. Okay, we don't like to send back a truck or a shipload of aggregates when it's not in quality. Mixed trucks have cleaning water scopes, are alt concrete trucks itself segregate, wrong slump, truck stop mixing, free fall limitations are violent, water added on site is the biggest one. And we know all that because this, the contractor doesn't want to pay for admixture, so the cheapest admixture is water. Okay, segregation at the pump. The next, please. You, by the way, you all get these, of course, in the manual. Ice and snow in mold. I wish this was a problem in the Netherlands. Spacers missing. We have seen somebody filming and self-compacting concrete pour where all the spacers just floated away. And of course, people are not going to stop the site because that's too much of a hassle. Now, big problem, demolding agents, too little, too much, too thick, formwork is removed too fast. In the past, we used to have wooden formwork, lost formwork, which was the fantastic curing means. Now the companies that have the mold, the framework, the formwork, they are there the next day to take it away. Okay. So too much time between demolding and curing agents not applied, too little, not repeated, etc. Plastic foil is blown away, etc. So here are all the problems shortly listed. I have not qualified them too much and not quantified, but this is a good base for this afternoon.
Thank you very much, Boudewijn. I think this is indeed a good starting point. We are clearly not living in a perfect world, and we have to take this into account also when we are constructing and we use concrete. So it's a good timing. We have just been on the 5 minutes. So the next speaker will be dealing with the inconvenient truth properties of Labcrete versus Realcrete. And it's really a nice title for presentation, The Inconvenient Truth. I would like to invite Harold Hol to give this presentation. And Dave, you have the slides on there. Mr. Harold Hol, are you online with us?
Yes, I am.
Okay.
Can you hear me?
I invite you to take the floor. You have 5 minutes, maximum 7. Please go ahead.
Thank you. Thank you for the nice introduction. The properties of Realcrete versus Labcrete. During a work, we did a lot of tests on concrete because the contractor wanted to know what real properties were. And by accident, we didn't properly cure all the specimens according to the codes. May I have the next slide? Then you can see what this was the work. The concrete was used to fill the gap between the prefab outer layer in an harbor and the wall, and so we did a lot of tests on that. May I have the next sheet, please? The concrete mix was the following: strength C30, environmental class XS1. We used a lot of cement in it, 370 kilos, and that was because we had a lot of steel fibers in it. You can see it below, 50 kilos of steel fibers, long ones, 35 kilos, and very short ones, 15 kilos. The next slide, please. And afterwards, we made a lot of test specimens, and about half was cured underwater in 20 degrees, and the other half was cured in air. And you can see what is happening. The water cured give the nice result of about 28 days for a C30 from 33 megapascal. Air cured only 36. Next, please. Next, okay. We did also the Young modulus, and what we found was that the air cured were about a third of the water cured. So the construction engineer was getting a bit nervous because he got numbers he wasn't used to. Next, please. Tensile strength in water was very good. And if you look up the model code, it was almost the same as the air-cured samples. We think that was because there were so many steel fibers in it. Next, please. If you look at the difference between the two realities, you see that depending on the condition, on the what you are measuring, comprehensive tensile of E modulus, the difference is about between 20 and 60% lower if it is air cured. Next, please. So only if concrete is cured underwater, you find the properties used in the codes. And depending on the curing conditions, the top layer of a construction will be at least 20% less durable, and in the worst case, 60% less than what you expected. Thank you very much for your attention.
Thank you very much, Gerald, for this very good and concise presentation. Nice in time. I think we have some time for questions. Is there someone from the audience who would like to put in questions? Normally you can raise your hand in the presentation. Is this the case? Anyone? Does anyone wants to comment on the presentation?
Johan, you have 2 pages. You have to look also at the second page.
What do you mean with 2 pages?
you see on the screen there are 2 pages for the
You mean
screen.
the chat, but I don't see anyone raising their hand or.
Yes,
Hey,
yes.
okay, Danilo,
Dan-
yes, go.
Dan is raising a hand.
Yes, please. We don't hear you, Danilo.
Good afternoon, everyone. Can you hear me?
Yes,
Yeah.
yes, now it's okay.
I just pointed on a question. I want to know more about the conditions of humidity in the air, which was treated the samples.
Mhm.
Can you describe more, please?
The humidity of the air cured samples was about between 60 and 80%.
Okay.
But then, from my experience, what we wanted to say, in ex-USSR countries, we usually cure specimens in air, but in very humid air, about 95% of humidity in the air. So these results are usually far more better than water cured. Have you been experienced such as different situation?
You mean
No,
steep curing?
thank you for the question, but no, we haven't had that because normally we don't have 2 samples from the same batch which we can compare, because most samples somebody thought we can also do the half outside the water tank. So that is one of the reasons we have this this comparison between the 2 ways of curing.
Okay. Thank you very much, Danilo. Gerald, I'm looking to the time. I will propose that we will come back to further questions when we have the discussion. One thing I would like to put on the parking to rediscuss afterwards, it's safety factors. And I would remind the word safety factors, and I would like to come back to that later on. So now I would like to skip to the next presentation, which is about particle packing, and which will before and after, and which will be delivered from a colleague from Kiev, Daniel Starkon. Daniel, are you with us?
Yes, I'm here. Yes, I'm here.
Daniel? Okay. Oh, that's the same man. It's good. Thank you. So you have also 5 minutes maximum.
Thanks a lot. I will present it from my screen if it's possible.
Well, I think we yesterday had the exercise and it was not that easy. So I would
can you see the presentation?
Yeah.
Now?
Yeah. Okay. Yeah. Go.
Okay.
Yeah.
So hello everyone. Thank you for possibility to share with you our approach for concrete granulometry optimizations, which perfectly works in a real engineering practice. We use it in KBNG Consulting, and I'm grateful for Mr. Barry Hudson teaching me how it works. Usually, I explain the mix design in a very simple way. I just compare it with the human body. Firstly, we should create a bones, so-called granular skeleton. Then we put some meat on it, which means binder and fillers, and then salt it with some amount of vitamins, admixtures. And this creates to the concrete some superpower. But my very clear message to you today, as a founder of Ukrainian admixtures company, is that with the broken leg, vitamins are not effective. If you have to fix something, you should first look on the granular skeleton and start your mix design from granular skeleton. Our methodology is based on manipulating the voids content. What really matters from the side of aggregates? This is simple 3 factors. Of course, grading, surface shape, and surface texture. Of course, there is much more characteristics of aggregates that should be considered in the mix design, but I will focus your attention on these 3 because they affect mostly the packing density. So what we do, we blend different materials, measure the bulk density, which represents the void content. It's very simple, just cone and the bucket, that's all. So, of course, our methodology is competing with traditional grading approach and specific surface concept. But I want to show you some example. There is one ready mix plant which is supplied by one quarry. They erected a new crushing line, and the old one you see on the left is with the old material with flakiness index 31%, 32, sorry. And on the right side, you can see, look on the video. So this is a totally different concrete with just changing the flakiness index from 32% to 11%. We was also very surprised that with the same formulation, same mineral, same RMC plant, everything is the same, just flakiness index moved. We have this kind of result. We have less voids, we have more paste, concrete is more flowable, more creamy, and this means that the grading was completely the same. And what about the specific surface concept? Just look on the left on this sophisticated analyzer for specific surface area and a regular batching plant. How far is it from regular engineering practice? So I guess cone in the bucket is pretty simple and useful in real practice. Our methodology started from building triangles for the visualization. For voids content optimization, we use a triangle with cement, fine aggregate, and coarse aggregate steps. So I will not have much time to describe you the methodology in details, but I put information on slides. You can later on look thoroughly there and ask me questions. Will help you to understand this. But in very short time, I will describe you. Firstly, we optimize the fine aggregate and the binder, and then we optimize the coarse aggregate voids content separately. You can also use this methodology, so-called Punkte test, to optimize the granulometry inside the binder. And then you put three parts together in the best proportion to have less cement, less CO2, more cost efficient, and that's all. So usually if the rheology is better, the compressive strength is also higher. And of course you have to do some fine tuning after the lab crit to the real crit, and check in the production all the laboratory results. Thanks for the attention. If you have any questions, you are welcome to ask me.
Thank you very much, Danilo. It's a very good and sharp picture, nice in time. We have some points for questions. Are there any questions? Please raise your hand. Boudewijn, yes, Boudewijn. But you will have plenty of time to all the faces on the screen, Dav, if possible. Yeah, Boudewijn, you had a question?
Yeah, I had a question. Would there be a possibility to have a void factor? That means paste to mass factor. Would that be a possibility? I know that the Danes are very proud in displaying that they have the lowest paste content. Wouldn't it be very interesting to have such a paste to mass?
Mr. Baldwin, you want to hear examples? You mean you want to share for me to share with you examples of my practice? I want to tell you that as far as I understand, you want to hear about the binder to aggregates content. This is the whole idea. So we pack aggregates, yes. How much we can. We put the less amount of binder that we can to and have the same strength. So we just cut maybe even better finishing properties and handling properties of the concrete. using this methodology. This is very simple and very easy to apply on regular batching plants.
Okay,
But we
okay.
have
So,
a-
It was developed in Danish institute, in professor that created UHPC concrete. Sorry, I forgot the name, but this methodology regarding the binding system optimization was created in a Danish institute. That's true.
we'll come back to that again at the discussions. So I understand that your proposal is to reduce CO2 emissions in concrete. You go for a better composition, you go for a better study so that you are really capturing the total properties of material. So thank you, Daniel. I'll go to the next presentation, which is also in the same field. It's about testing reinforced concrete under real conditions on site. And it's Michael Hartel will give the presentation. I see, Michael, that you are online. So Dave, if you can share with us the presentation of Michael, we can start the session, please, Michael.
Yes, good afternoon. Can you hear me all?
Yes.
Okay. So in the last 2 days, we heard a lot about the methods to reduce CO2 in concrete. And Thomas and Johannes told you about the Vienna project where we plan to use RCC concrete in a skyscraper. And speaking with Baldwin last days, we found out that it is for the realizing RCC on real projects. We have not so much heard about what do the workers with that, and what is the construction side thinking of. And so I will begin to speak a bit about the problems we have to realize RCC in Vienna, and what next slide, please. Yeah, what the reasons are why we are testing on site. So we have heard a lot of lab concrete about methods to do reducing CO2 in concrete. And what we not heard already, or what we are, what's hard to see is real projects. Yes. Real projects and how to bring the RCC in a project what is designed with standard concrete. And the big problem is a bit, next slide, please. Dave, can I have the next slide, please? Yes, thank you. The problem is a bit that the culture of our construction is a bit different. We had in the past the first concretes, this is the green line, and the concretes now, or the concretes today, are high potential concrete. Yes, they are high-tech materials that are optimized to make an easy handling on site. So the work, this is the blue line, the workers have to do to bring the concrete in the formwork is getting down. And I made a horizontal line, so we can do with super plasticizers, with retarders, we can optimize the concrete so that it's very easy to handle on site. And the horizontal line is given by the rules, the national rules, and the normative to what we have to do in curing the concrete and how to bring it into the formwork. The dot line I have seen is that what sometimes we can see on site. The people, the workers, use the high-tech material to next slide, please. Dave, can I have the next slide, please? Yes, come back, please. 2 slides back, if it's possible. Okay. Yeah, this is standardizing the rules, and so we see on site that we have sometimes a less curing. Next, please. Next slide. Yes, and they do everything to save money. We have heard there are some mistakes on site, and we have sometimes less skilled workers, they can use the concrete as well, because the concrete is high tech. It does everything. It is sometimes self-compacting. It is good to bring in, and we have no problems with standard high-tech concrete. I don't want to say everything because I have so less time. Please go to the next slide. Yeah, and this is the problem. An RCC concrete needs to be cured, needs care for bringing it in, to pour it. We have to cure it. This was Bodin said is very necessary. And as Johannes Horvath said, we need guidelines to use that. We have some, but not for every concrete concept. And this concrete we now want to use, we have no guideline. And so we are going to test that to come from the Labcrete. We have laboratory tests a lot, but we need on-site tests to see what we can get, and we can handle that. In the next slide, I made a sketch what testing brings us forward to use the RCC concrete. Practice for the workers, reducing the prejudice and the fears of the contractors that this is too expensive, or they can't handle that, or the quality is not good enough. Getting RCC handling information means quite the same. Getting more knowledge for guidelines. We are designing guidelines. You have heard yesterday from Johannes Horvath. We can test the environmental dependent curing requirements. So the temperature and the curing with shapes we can give over the concrete. Formwork, stripping, calibration. When can we get next formwork free? And then we have, this is a test field we did in summer. We had 3 walls and slabs where we did different curing methods, and we tested not even the cracks. We tested also the temperature, and we tested the hardening process, and we tested in summer, for example, the handling of the concrete, and we get positive results from the workers that it was easy to handle, better as they thought before, and we got useful information to calibrate the mixture for real use. And this is what we think is necessary to get common with the contractor, that the material, the new materials reducing CO2 is also an easygoing product on site. The last slide, please.
Okay.
Dan, can I have the next slide?
Please? The next slide, because we have to conclude. Yes.
Yes. These are the results. Johannes told that we have some results to produce today. Maybe you can look in detail at the given information here. Concluding, it is we tested some thickness walls and slabs and the curing effects, and now we are in the way to give an advice for the site to use the concrete on the real building. Thank you.
Thank you. Thank you very much. Apologies for the beginning. I was referring to reinforced cement concrete, but it's about reduced carbon concrete. It's a new terminology. It's important, and it's this kind of exercises, demonstrations, which we will need to convince contractors to use the new materials. So I see we are very limited in time, so I skipped the questions. We will come back to the questions, Michael, in the discussion session. Thank you for your presentation. And I would like to go to the next presentation, which is in the same field. So it's good to have some discussion afterwards. It's about the verification and coaching for using geopolymers of ProRail underpass, and it's Tom van Beek who will deliver the presentation. Tom, the floor is yours.
Thank you, Johan. I'm Tom van Beek. Everybody can hear me?
Yes.
Yeah, okay. That's very nice to hear. I'm Tom van Beek. I'm from SKG ICOP, a certification institute, and I'm going to talk about how we dealt with an example project for geopolymer concrete, geobeton in Heilo. So next slide, please. To start with, I first have to explain what verification is, because we as a technical manager at SK Hiko, normally we are doing tests for certification, and we are going by the companies, ready-mix concrete plants, for example, to see if they do their checks, they have their Labcrete okay. But now we had something very different, something innovative, concrete. How do you deal with this innovation? This verification is explained by me by this two axes. One is early research, a brilliant idea. And when is it available on the market? The horizontal line and the vertical line. In the beginning, you have no standards at all. And in the end, if it's completely, you have a lot of standards in the vertical line. Next step, please. So you begin in the beginning with R&D, a self-declaration of your product, in which you say it's brilliant. It has a low carbon performance and very high strength. That's normally what everybody says of his new product. Then we are going on later, but there are no standards in the beginning because the product is completely new. It's not within the current standards we have for concrete. And so we have to see how to deal with this performance claimed by this the man who made the facility that produces the concrete. So only after many years normally you can go to standards and go to certification, but this time we use a verification. Next step, please. This in this verification we didn't need certification yet because we only want to have credible performance data of this new product, this geopolymer concrete. Next step, please. And we do this by prototyping, and high-low was kind of prototyping. And this verification process was done in, this is presented as a linear process, but I can tell you it wasn't really linear because it was a lot of debate, a lot of discussion. But we started with a brilliant idea about building this underpass with a wall in it from geopolymer concrete. There was a design, a technical design, and with and a lot of material parameters from the laboratory, the Labcrete. And that was the first assessment. Can you make with this Labcrete concrete a realcrete structure? So we made the first report. It said, okay, if you look at this data, it should be possible. And then we went to the control situation in the real time during the construction. And in the end, we made a statement. The following performances were valid with a lot of data of the contractor. So we had a lot of data. In the end, it could be used in practice. Next slide, please. Because the performance of structure, it can be of many different types of performances. And I took the 7 normal performances of a structure as stated by the European Committee. And we have the mechanical resistance stability, the safety in case of fire, hygiene, health and environment, safety in use, protection against noise, energy and economy and heat retention, and sustainable use of natural resources. But not all those performances are always applicable for every structure. So in this case, we did a risk analysis and we said only the mechanical resistance, the impact on the environment, and the sustainable use of natural resources were looked upon. And so we had asked the contractor, how do you give me as a certification body your performance of the structures, and what are you going to deliver me as proof that this mechanical resistance, this leaching to the environment, and this is still the low carbon impact will be proven. Next slide, please. Now, so the performance of the structure, a lot of lab tests to begin with, just to get a good mixture, etc. We also asked them, how do you give instructions to the ready-mix concrete plant? Because they have to make this concrete, and they never made this concrete before. How are you going to learn these people that this concrete is the same or different, and what are the differences also on safety, etc. The same was on the instructions on site. Are those people working on site well informed on how to deal with this new type of concrete? And if this concrete is in the structure, and you see here a picture of a mock-up they made before they really made a real wall. And this was one of the methods to learn how to deal with this concrete. and how to do tests on this concrete. So not only lab tests, but also a lot of field tests to see if the curing compound worked well, etc. And also we got a life cycle analysis from this concrete structure to see if this really low carbon, was a carbon dioxide reduction, yes or no. The conclusion of this complete process, it was rather funny because it was designed as a concrete structure. Well, we all know that geopolymer concrete is not concrete, but it looked like concrete in practice. It behaved like concrete, poured like concrete, and there was really nothing really different. One difference there was a lot of attention by a lot of people who were looking at it. I've never seen so much quality control on site than during this project. And in the end, the performance of the concrete, mechanical, etc. Yes, most of the performances were met with ease, to be honest. Also, the difference between lab test and field test, as we heard before, if you took the safety factors into account, it was okay. Thank you for your attention.
Thank you very much, Don. It was a very interesting lecture. Also, working with these new materials, but still making reference to the construction product regulation. So trying to show that this material, as you say, behaves like other concretes, and you can follow what's happening with the necessary verification. I thought you spoke about a linear process. Did you say a linear process? I would just suggest we have to go to circular processes. Everything in the future should be circular. So feedback from your testing to the lab, but I'm sure you're doing that. Any other questions for Tom? We had some questions in the chat I've seen on the presentations which will be shared. I see that Boudewijn has a question, but Boudewijn, just stand by. I look if there are other questions. If it's not the case, Boudewijn, I'm pleased to come back to you because you're the organizer in the first place. And I understood also we will have now some 5-10 minutes discussion, also dialogue on a presentation which was given yesterday. Can you address this also, Boudewijn, if we stick to this program or if we change the schedule a bit? We are not too bad in timing. We are in my timing, okay, but not really in the one originally planned, but yes, please, Boudewijn.
Yeah, just to comment on the presentation from Tom. There is a very important dimension to this verification, and that is the coaching, okay? Because you're doing something new, and you don't hide behind a standard. They say, look at Article 2.5.3. You are really getting into a new field with a lot of attention, like Tom said. So the coaching aspect of verification is also very important. So for any type of pilot, we are available to copy, paste everywhere on these new things, immediately very high consequence classes, you know, where you take big risk. So that's what thank you, Tom. So right now I have to improvise because the two people who were supposed to hopefully linking in with this session, they could not.
Are you talking about Evelyn and Kees?
Correct.
But I propose that we skip this thing to the dialogue at the end, Boudewijn. Then we will be nice in time with the other presentations.
You're the boss.
Yeah, maybe we have more chance at that time that they are with us. So I would like to pass on the floor then to Julie Pirard, who's from our institute in Belgium. Julie will speak about curing and a project she's doing on testing curing products. Okay, I see the slides from Julie are on. Julie, you are with us?
Yes.
Yes, please. You have the floor, Julie.
Thank
7
you,
minutes
Johan.
also for you.
7 minutes. Oh, thank you. Okay, good afternoon, everybody. Yes, I have only a few minutes. It's very short to convince you of the importance of applying a good curing to concrete and to be able to assess the effectiveness of the curing compounds that contractors are using every day on construction sites. Next, please. First, a question: why is concrete curing so important? As you know, curing is the process of controlling moisture loss from fresh concrete. If no curing takes place, water will evaporate due to sun, wind, and hydration heat, so that not enough water will be available during the early hardening process. Next. Thank you. The consequences can be dramatic, such as a bed strength development, cracking due to plastic shrinkage, thus reducing the lifetime of the concrete, and also a bed appearance. Next, please. You see here what can be the effect of curing duration on the compressive strength development of concrete. No curing in the yellow line on the graph leads to a drastically lower compressive strength than that obtained when applying a moist curing. But we have already seen other examples in the previous presentations. And in addition, we have to keep in mind that new habits, such as the use of additions in concrete, make it even more sensitive to curing than OPC concrete. Next. So remember that curing is a simple step that is often neglected, but can make a huge difference with respect to the lifetime of the concrete structure and makes it possible to get the most out of concrete. And this way we can say that it leads to a reduction in CO2 emissions. Next. One of the easiest ways to cure concrete in place of conventional and prolonged wet curing is to apply a liquid curing compound on the concrete surface. How to do that? By spraying the product immediately after placing and finishing for a floor or a slab, or of course after demolding for vertical surfaces. When correctly applied within recommended dosage, it forms a surface film that reduces evaporation of water from concrete. These chemical products are mainly waxes or resins emulsified in water or solvent. They can contain pigments that are useful to check the cover area and also to provide heat reflectance. But be careful anyway, as most curing compounds have to be removed prior to applying any coating. Okay, next please. Here you can see some types of concrete elements on which curing compounds may be applied, such as roads, bridge decks, walls, and slabs. Next. For all these applications, there is an obvious need for a reliable test method to quantify the effectiveness of these products to be sure to obtain a high quality concrete. Next. For this reason, we have initiated a research project in Belgium. The main goals are to refine the existing test methods, but also to review the criteria used to decide whether a product is performing well or not. Next. Thank you. A European technical specification provides a water loss test in lab for the qualification of curing compounds. Yes, next. And based on this, some European countries have published their own modus operandi. In Belgium, this is included in the technical prescription published by the certification body BCERT. And this document do not yet give full satisfaction. And as a result of our research work, we hope to be able to publish a revised version within 2 years. Next. The principle of the lab test is simple at the first sight. It's a matter of comparing the loss of mass of specimens covered with curing compounds with that of reference specimens. But there are many parameters involved, including the concrete mix design, the way of removing bleeding water, and so on. So the method often exhibits large variability in test results, and this makes it difficult to decide whether the curing compound passes or fails the test. Yes, thank you. The project also aims to revise the minimum effectiveness criteria for the curing compounds. In previous research works in Belgium and other countries, the evaluation was based on the loss of compressive strength of the concrete in comparison with specimens that had undergone ideal curing, as you can see here on the right on this graph. For further research works, we think it will be maybe a good idea to consider an evaluation based on some durability indicators, for instance, water absorption or carbonation resistance. Okay. That's it. These are some reflections that I wished to share with you. Don't hesitate to contact us if you have any questions, any comments. Thank you.
Thank you very much, Julie, and perfect timing. There's some time for question. Is there any question? Someone who wants, Danilo, you have a question, yes?
Thank you for the presentation. For me, it's interesting. If you compare it, have you compared the traditional water bath method, just putting some water on the top and maintaining the level of the water, with the curing compounds method, from the point of view of durability and compressive strength?
Yes, the reference specimens were covered with a plastic foil, not with water, to have an ideal moist curing. And from now, we have only compared the compressive strengths of the specimens, but we have the idea to also do an evaluation based on these indicators, durability indicators.
I just want one point that I want to consider that I want to mention that there is some research works that shows that how much water you keep inside the pores, the most durability you will have. So maybe this special addition of the water on the top, if the concrete is pre-hardened a bit, will help with the durability. If you will try, I will be very grateful to see the results in your research project.
Of course, yes.
Thank you.
Thank you.
So, thank you much, Julie, Danilo, for the questions. I propose we move on to the next presentation. We are nearly 1 hour going on, and still everything is under good control. I think we have a next presentation, which is about multi-grade, multi-variable custom control. So we stay in the field of control, helping for CO2 reduction. And it's Barry Hudson who will give the presentation. Barry, you are with us?
Yeah, can I share my screen? I've got some animations in here that will probably be a bit easier for me to do.
I'm pleased to hand you over. Okay, thank you.
Thanks.
Yes, please.
Yeah. Can you see my screen?
Yes, yes, go on.
Okay. So thanks very much for inviting me along to present today. Boardman, it's a great idea, these 5-minute presentations. They should have invented these years ago. I like them. Presentation is on QSUM for concrete QC. Something that is a very, very, very simple process. Again, looking at control and looking for out of control variables, how they relate to each other, and how you can reduce binder content, costs, and CO2. So QSUM, or cumulative sum control chart, is a sequential analysis statistical technique developed back in the 50s, and is usually used widely in the concrete industry. I started using it myself back in the 80s, showing you how old I am, and had fantastic success with it. So looking at QSUM, you'll check whether or not target strengths are being achieved, measure variations from target, and identify any magnitude of any variation. It's a very, very simple statistical method to look at trends and control processes, and it's easy to do in Excel also. So the principle is the difference between the results and the target values are calculated and added cumulatively to form a cumulative sum. And then you graph this cumulative sum, and that gives you a very, very simple presentation of any trends that are happening, positive or negative, and in the case of wanting to reduce binders, etc., trying to keep the concrete performance as far as compressive strength goes, in this case, on target. So to start this, the first thing you need to do is define your target strength. There's a few different ways of doing that, but the basic things that you need are characteristic strengths, standard deviations, those types of things. I won't go into the different methods of defining target mean strength, but the basis of this is to have a target strength that is statistically achievable for you. Then the target strength is along the x-axis here, remains 0 QSUM. So if you had all your results came to exactly the right target strength, in this case 34.5 megapascals, the trend line would stay flat at 0. Of course, we know that you very seldom get 2 test results in a row that give you the same result, let alone the same test result within a batch of cylinders or cubes. On the y-axis here, we have cumulative variation from target strength, and I'll just have a very, very quick little animation to show you how the system works. So the first test result that you have, remembering the target is 34.5 MPa, and you get a test result in the series. First one is 37 megapascals. The plot value will be 37 megapascals minus the target strength, which is a cumulative value of 2.5. So on the graph down here, we have a line that says we slightly above target strength. The second plot at test result would say 38.5 megapascals. And the plot value would be 38.5 minus the target strength again, plus the previous QSUM value of 2.5, giving us 6.5. It's that simple, that rudimentary. But you can start to see that as we have 2 results that were greater than the target strength, that the line is moving in a positive direction. Remembering the target is to keep it at 0. So as you go and add test results, you keep building this trend line, plus, minuses, etc., etc., until you get to the stage where things are out of control, or something needs looking at, root cause needs to look at. And there's a couple of ways of determining whether or not the results need to be looked at. The first one is if you have 5 consecutive results that trend up or down, is an indication that there is something changed within your process. Or there's a thing called a V-mask, which looks at different process levels for desired consistency, and the amount of consistency determines the width of the V-mask. But you can put the V-mask over the lead point here, and in this case it's very, very tight, but it would go wherever the line crosses, would tell you that there is an out of control situation. As we can see here, the first line crosses here, and also corresponds with 5 poorer than desirable results in a row. Then looking at an individual mix over time, here's a good example of concrete that's not in control. You can see there's many of these masks where the lines are crossed, and you also have areas or strings of data that are below or above your target. So this is a good example of something that we would consider not to be in control. So that's for a single QSUM. There's a couple of different ways of looking at this, and I think it's one of the strengths of the methodology is that you can actually look at many different variables that have nothing to do with concrete materials themselves or concrete materials, constituent materials, etc. So we have the multi-grade QSUM, is where we can at one point in time have a look at all the different grades of concrete that are coming out of a given plant, to look at variation, etc., to try and determine whether or not it's a concrete material related problem. Then we have the multi-variable, and anything that you can assign a target to, you can use this QSUM method for. So, basically, you want to have it based on the same time frame. So you can have a look at plant efficiency, constituent materials, quality, labor, weather, anything that's measured and can be defined. You can run exactly the same analysis. And so when you start to see that the that the trends are having 5 in a row or cutting the V mask, you can go and have a look at these other materials and see if you can find the answer. And it's ridiculously accurate, not the right. It's ridiculously good at finding the root cause for different problems. And then obviously optimizing compressor strength and therefore binder quantity and type. If you're trending too high all the time, obviously you can remove binder. That's the loose link to CO2 in this particular presentation. But the big driver for QSUM is consistency. And we all know that the more consistent your product is, the more economic it is to make and the more surety you have on the end result. So that's one of the reasons why it becomes especially powerful in concrete. Now there's lots of, like in Daniel's slide before where he had the specific surface measurements versus concrete plants, that's a very important point to be made in everything that we do, because the industry is a lot more rudimentary or basic than we give it credit for. Concrete producers, I've been managing director for some of the largest international corporations with concrete, and you'd be surprised at how poor things are. So yeah, it really pays to keep things simple and get the low-hanging fruit, as they say.
Thank you.
And
thank you. Can we conclude, Barry? Because we
yeah,
have.
I'm just about to finish. I've got two bits. So remembering that when you look at variability, genuine QC and done in aggregates, very, very poor, 80% of the volume of concrete. Over 75% of the world concrete is batched with three or fewer aggregates, bins and silos. Keep it simple. The industry is not lab-created. Methodologies need to be robust and simple. So that's it.
Thank you very much. So we go back to Martin, and we can look to introduce the next and the final speaker, who will be João Manuel Pereira, who will talk about also aspects of the state of the art on quality assurance. I see that you are with us, João. The floor is yours. You have until, let's say, 12 minutes past 4. Yes,
yeah.
Please.
Hello all, good afternoon. Thank you for this opportunity. I'm going to speak about our company, our product, our services, basically. We are a company that has one product and one service. Okay, it's quality control and mix design software for the concrete. Okay, and we do this consulting for QA/QC, consulting for mix design, concrete technology in general, and now the digital transformation of the concrete industry. Okay, so please, next slide. No, you skipped one. Yes. So digital transformation, okay? We're speaking about 4 pillars in technology, specialized software such as the one we have and the one many people have, okay? Sensors and monitoring, which is something that is booming at the moment and will keep on growing in the future, okay, with Internet of Things and all these things. Then linking the systems together, which is something that was hard in the past, it's really easy now, okay? And automating tasks. Automating tasks is not having a robot. This is not Star Trek technology. This is something that we can do today. All of these things exist today, okay? And the challenge here is to put them together in the right way, okay? This is how we transform the concrete industry, and we get these improvements and this performance-based system that we've been discussing these past few days. Okay, so next one, please. Next slide, please. Yes, thank you. So concrete is in our DNA. We, myself, I'm a concrete man, an admixtures man. I worked in ready mix, I worked in admixtures, I worked in precast, all with this quality control, quality assurance, and concrete technology, materials technology focus, okay? And then I also became a programmer. So I have these 2 hats, okay? And the people I work with, my team and partners, we all have these backgrounds, okay? So we found a very, very good way to put these things together and improve the processes, okay? So next one, please. What I mentioned before, all these 4 things, we put them together, okay? We put together the ready-mix plant, we have in-transit monitoring, in precast, things on site, okay? What we've been discussing as well in the past presentations, okay, about the real crits, knowing what's happening on site, okay? And trying to connect everything related to this QA/QC focus. Okay, QA/QC with these 2 aspects, technical, okay, with the statistic, with the QSUM, with the particles packing, with all these methodologies, and also documentary with traceability and knowing what's happening so we can trace what has been done to the result that we get in the end, okay? And this can be starting at the batching plant, the process, the transport, and what's happening on site while in the pour, while it's curing, and then long term, okay? We put everything together, okay? So next one, please. And the idea behind that is that we can achieve this 100% visibility over the whole process. No dark spots, no blind spots, no not knowing what's happened, okay? Whether by the system itself, by monitoring, okay? And this is the concept is that this is fully integrated into this quality management and business intelligence software, okay? And it becomes a driverless system, okay? Driverless like the car. You tell it where to go, and it takes you there by itself, okay? So all the analysis, all these things happen automatically, okay? This system can read an email with a PDF from a lab, okay? Automatically, put it in the database, analyze if it's right or wrong, tell somebody you need to take a look at this, okay? It checks the plant and tells the people on site if they need to, something happened at the plant, the driver did something in the way. All these things, they happen automatically, okay? So next one, please. And I take 1 more minute of my 5+1, okay? This is something I say, what happened with admixtures will happen with sensors and monitoring and this digital transformation in general, okay? At first, nobody used these things and nobody did what to do, or knew what to do with them. And now it's unthinkable to work without them, okay? So next one. And this is the last one. You can read what's there, but imagine what could be possible if we knew all these things, if we had much better control, if everybody on site knew that everything was perfectly controlled, Okay, that if I add water to the concrete, someone else will know. That if I don't cure it correctly, someone else will know. How will people behave? Okay, how will organizations change? How will the culture in the concrete industry change? Okay, so we think this is the best way, but automating these things to take this LabCrete, this TheoryCrete to the RealCrete to make a real good and immediate impact in the industry, because this is something anybody can apply, okay, and has immediate value and immediate impact on CO2 reduction with cost reduction, optimization, etc. Okay, well, thank you.
Thank you very much, Juan. Thank you very much for staying on and your timing. I would like to express this gratitude to all speakers, which have done very well. I would like to strive to make a summary for myself about what I heard. I found it a very interesting session with a lot of interaction of the topics. I think it's nice to see that we are working on, even have a name for it, reduced carbon concrete. We're working on that. We see that a lot depends, of course, on making good compositions, on particle density studies like that. Of course, also on binders, like we heard yesterday. Very important for the reality is the curing on site, taking care of the concrete, because of course, we are having to face these outside conditions as we go. I feel it was very nice, Ewan, that you made the link between our green endeavors or carbon reduction and the digital. Digital as a key enabling technology to achieve this. Because indeed we are not living in a perfect world, so we need to do some verifications and controls, as has been indicated. And we don't have to do these verifications and control just for the sake of controlling, but to build trust, because making our structures, it's all about building trust between the different partners who interact on that. And for that, we need, as you say, a full view on what happened in the future. And I think what for me is the point that I would like to come back to later on in the discussion is the safety factors, as I said in the beginning. Because if we have no trust, then we have to increase our safety factors, and then we are spoiling material, and we are not as carbon friendly as we want. So we have to work that we have better mastering safety factors, and mastering safety factors is also a question indeed of measuring on site, controlling what we are doing, and being sure that we can lower the safety factors, because we know that what is on the site is really what we hoped for to have. So with that, Boudewijn, I would like to hand over to you and Wolfram and Jacqueline for handling the three other points we had on the agenda. I see we still have quite a quarter of an hour. We still have 30 people in the room which stayed with us from the beginning. It's nice to see. It must have been that it's interested, otherwise people would not have stayed with us for listening to your very interesting speeches. So Boudewijn, I would like to hand over that you take control for introducing or further this discussions topics, and of course I would be happy to interfere also if it would be taking too long. Okay.
Thank you, Johan. I just have to go a little bit back to what we discussed previously. And my question is maybe a rhetorical question almost. Are we getting the data we need? If we get the strength of a cube on 28 days underwater, I cannot imagine that the structural engineer, he has maybe read it in his book from school, but he is, it's not very useful. And then you say, oh, well, just double the size of the concrete, we get security, no problem. We cannot do this anymore. We have to start doing more with less. And that means we have to know what we are doing. And I have the feeling that we do not know what we are doing. So we only know this 28 days called crushing strengths. We don't know about flexural strengths. And yesterday, Kees Kleinman had a whole shopping list or a Christmas list from things he would like to know. And if he says, I need elasticity module, and we don't know that elasticity module of the realcrete. So this is my big point. We cannot answer this today, but I really would like to invite as many people as possible to say, this is what we can do. And I discussed this already with Barry and with Dan. Maybe the people in Ukraine, they are highly competent. Maybe we can ship every week a pallet of prisms of 15 by 15 by 70, gather information of the realcrete, cured, not cured, etc., etc. I think that the owner would like to know what he has. I think that the structural engineer would like to know what he has, and he does not right now. So I think this is an enormous challenge of the business. So I will conclude that on the content. The curing I'm extremely worried about, but because a friend of mine from France, he said, François de la Rare, by the way, he said, horizontally we cure sometime, vertically we don't cure. Almost not. Okay, let's moderate it a little bit. Johan, I see you shaking. So
everything will depend on the structure, I think, by the way, and everything has a price, and of course we have to take this into account also. I follow what Johan is saying on the need of controlling. I would call it monitoring. We need to monitor. It's also what we apply in soil mechanics. I had Professor De Beer, and to come back to the safety factors, safety factors of 1.5 and 2, these are safety factors. If you go to 3, then it's because you don't know what you're doing anymore. But as soon as you start monitoring, you can reduce safety factors. And this is, I agree with you, we have to do it. We have to build trust. Definitely with the new concretes, we have to do this very nice tests and monitoring of tests and follow-ups of tests and verification of tests as we have seen them. And I trust that in the next years, this is what's happening. This is what's coming up. People are getting ready to accept that we need this reduced carbon concrete. And I think the market is there also because clients will start to ask it. And as soon as clients start to ask it, then the producers will have to follow, and we will have to be there to watch what's happening, do monitoring, do the verifications, and build the trust all together to come to lower safety factors so that we can use the material as close to its potential characteristics it has. And this takes, I think, a lot of collaboration, because I heard the speech yesterday just to launch now the discussion maybe on what does the structural engineer has to know. I think one structural engineer cannot build any structure anymore of importance. We need to collaborate on all levels and have a lot of trust between all these levels, because a single engineer, of course, he can build his single house, but we are not dealing with this kind of projects, I think. So we need really to make this differentiation also in projects, because one project is not the other. Building the Burj Khalifa is not the same as building a house using maybe earth and cement admixtures in the middle of Africa. And we need to adapt our verifications or controls or materials in a way that we think global, but we act on a local scale, taking account of the local conditions which are at hand. Yeah.
Okay, Johan, if I may, one more question to Juan Manuel, and then we will go on to the general reflections of these 3 days. Juan Manuel, can you with sensors check if curing has been done, yes or no?
Yes, there are different sensors that can do that. Basically, what our system does is connect to anything you have. We have also partners that can provide this, but basically we work with whatever's on site. There are like meteorological stations. We get the weather data automatically. Also, there are sensors that can be placed inside the concrete or just on the surface. And basically, these are moisture sensors. Okay, these are good enough. And also, there's this psychological effect that I mentioned, that if you have monitoring on site, if you have sensors, people behave better. Okay, and also you can detect when they are lying to you, which is one big trouble in the industry. People lie a lot, because if there's a blind spot, people will lie. Of course, if there are no blind spots, it's much harder, you know.
I think there's a nice quote in the chat also from Herr van der Zanden. Herr, can you comment yourself on your post in the chat? I like it very much. Herr, are you there? Yes.
Yes, I'm no specialist in concrete, but I'm following with a lot of surprise, I must say, the discussion about the quality of quality control, difference between air curing and so on in the laboratory. Is it not better to change more to prefabricated products where we have much better control and less risk? And also it will be good for the environment, and I think also for the costs.
Yeah, I think it can be a point in some applications. It can be used. I think what we see is that with digitalization and industrialization, we're moving in this direction. But of course, not everything can be precast. Not everything has to be able to finish in this way. But again, I think it will need an analysis also on this point, taking into account more transport that you have and things like that. But definitely this is a solution. But I like that the quote you made, which was really indeed, and this is what we are too much doing, I think, that the quality of concrete is often a lack of control to be solved by adding extra cement. And I think indeed this is something which is happening sometimes by the prescribers, saying, okay, there's no control, let's go on the shore side. So it's coming to what I mentioned also, you increase the safety factors so that you, even if a lot of things go wrong, you still will survive. But I agree that if we look to environmental concerns, we might have to tackle this in other strategies by other processes, and industrialization can be one of them.
Yeah. Okay.
And I think you address it also in the manual, because maybe it's a good point, Boudewijn, that you discuss somewhat more about the manual, because the manual, as I understood, it's not only about binders, it's not only about prescription control and things like that. It's also about other processes to be used, looking to recycling and so on. I think, Jacqueline, this was what you defended also in the Beton Accord, that you look to the different ways to achieve this carbon reduction.
That's correct.
Yeah.
Well, shall I
please
continue? Yes, this is a good point. And yesterday, all the options for improvement also showed that it's not only about materials, but also about design and reuse and recycling. And only when you take all the options into account, which we call the ladder of circularity, the 10 steps. If you don't do that, you can't achieve the high ambitions that we in the Netherlands set ourselves for 2030. So, and that was a conclusion based on the manual and the ideas, among others, of Boudewijn. So I really like to urge everybody here in the session to read the manual and also respond to Boudewijn about their view on what is lacking or can be improved or whatever, because he's always saying it's a living document. Well, but the other thing that we also concluded the first day was the importance of the contractors, the clients, both public and private, who together with the structural engineers really have a role to play in making concrete more sustainable by indeed asking for performance-based requirements which need to be addressed by the market. And the market in the Netherlands is also asking for this kind of level playing field where all the contractors ask in a similar way, and then they can act upon it accordingly. And finally, I also like to make the point discussed today, that is, how are you sure about the quality control of everything that you try to innovate? We have a program now of about 15 innovations that have to be developed in the course of the coming 5 years. And in order to make sure that these innovations really perform like we hope and we put on paper, we need both a monitoring system for the quality control, and we need an assessment of the environmental impact that can be reached if you put all these innovations into practice. And that relates to the points made today about quality. Of course, it's very important. And also the link with digitalization is important, because then you can be much more precise about what you do in the whole value chain. So my last point is, I really like this, 3 sets of meetings where we share not only our experiences in the Netherlands, but also in Europe and even internationally. And I would really like this to be continued in a way that you as experts also provide input for what we do all over the world, and that you exchange all your knowledge and expertise, and that you also provide me, for instance, with some of the measures that need to be taken, for instance, at the EU level, in terms of Eurocodes and other standards that at least have to be interpreted more flexible in order to really make sure that in practice you do what you like to do in terms of minimize the amount of materials needed per unit of product. So my wish is that people in the audience who think, well, I have ideas about what should be changed in the EU context in terms of legislation or other measures, please let Boudewijn know, then he will tell me, and I make sure that we also have a good conversation based on our experience in the Netherlands on how to move on with adjusting the regulations according to the needs of better performance of concrete. Thank you.
Thank you very much, Jacqueline. I would just, as a final touch, bring it to one level higher, that you say the Commission, yes, but it's a global thing. So when I say a global thing, I'm hearing globe, and I see that Michael is there. Michael, I think it would be nice, as globe has been also mentioned in the initiative, maybe that you have some final word, because indeed we need to do further action, and I think globe is also pleading for this and could be a motor for having this going on.
Yes, thank you so much, Johan. Well, it has been extremely joyful to look at the interesting presentations here over the last couple of days, and it bears very good prospects for turning around the developments which are required for sustainable built environments. But we need at the same time as we are doing this, we desperately need to make sure that we work in parallel and maybe even harder on the global scale as on the national scales. It does not help that we will reach the goal line in 10 or 15 or 20 years here in Europe and in other developed economies. We essentially we need to be worried about what is going on where they don't have the luxury. We have the freedom to develop and to invent. So right now we have the developments in Europe with the revisions of the structural Eurocodes. And in my opinion, this would be the right point in time, the exact right event to take a step which has a more global, let's say, impact. It would be to intervene in the process. I'm sorry to say it like this, because they are just about 1 year from now closing the revisions. So it's high time to make sure that this new revision of the structural Eurocodes actually has adequate measures for ensuring sustainability in the built environment. I think that this group here and other groups as well should make a case. The politicians, they are not aware of what is going on in the revision project of the Eurocodes. And I'm sure they would be surprised to find that there are absolutely no provisions for sustainability in these ongoing revisions. I think it's our duty to make this point. And it seems like you're the right guys. I'm very impressed. Thank you.
So, Boudewijn, back to you. It's just...
I would like Wolfram to jump in also, because he is also very much a link from theory to practice and back. Okay, so maybe Wolfram could say also something about this QSUM very quickly, because he has dreamed of using that for CO2 reductions, which demonstrates that quality assurance leads to CO2 and material reduction. So Wolfram, please.
I'm
yes,
sorry,
thank you.
Thomas Rom raised his hand
a
little while ago.
Thanks. Thank you. I don't want to frustrate the discussion, but Michael and me in our RCC research project, we are just about to evaluate the costs for curing horizontally and vertically, and also the costs for monitoring by concrete mode application. And it does not look good. Yeah, it's a part of the reluctancy of the contractor for sure, but effectively there are costs, and this is building time most of all, but also working hours and working labor. So we have first to evaluate this and compare it to the reduction of CO2. And at the moment, we are about a range of 500 euro per ton CO2, and this is really a lot. I mean, I don't want to frustrate our optimism, but it does not look so very good. So we have to do research and practice first before we apply all this. Thank you.
Well, but there are also options that are still valid just to put in place. You know, that's what we have to do. We have to see what can be done now, what can be done tomorrow. If we don't speed up the process by doing, and not only by more research, but do the combination of both, then I think that we can really speed up. But anyhow, it's yours. The floor is yours.
Basically, I passed it on to Wolfram to make a jump back and a jump forward.
Okay, thank you very much, Boudewijn. And maybe what I can say certainly is also connected to what was said before. You asked me to give a short reflection about the last 3 days. I really enjoyed it as well, very much. I was skeptical about the format, but basically I liked it a lot. After these 3 days, we were talking about procurement politics, materials, about products, about different tools that can be used. But what I can observe, and this is probably addressing to the point that Thomas Rom raised, is that there are a lot of people having different interests, having different reasons to act. And everybody is trying its best, his or her best, to make a change towards more sustainability in everything. But we can also identify that everybody is seeking for orientation, is seeking for a kind of a hold. And therefore, there are a lot of initiatives, new agencies are being formed, new policies are being started, and so on. And it's getting more and more complicated. And I think this is what we are fighting with. So every new initiative raises the complexity, and nobody really knows how we can get there. So we have to find ways to synchronize and to harmonize somehow at a certain point in time all these efforts that are being made. I think that is one of the major challenges that we have to observe. And one thing, and if I look at this audience, there was a very good discussion here, but one thing that also one of my younger colleagues raised yesterday after she attended the conference, the audience is not comprising of, let's say, a mirror of the entire population of the world. Most of the people here have a lot of experiences. They have a lot of work experience from how concrete developed over the course of the last, let's say, 20, 30 decades, probably. But sometimes those people who don't have this experience, they ask the right questions. Maybe it's a apparently stupid question, but it can be a trigger for an innovation. If someone doesn't have that experience and asks without any bias. And what I can also observe, and this is a point I raised already yesterday, when people were talking about the engineer, it was always a he, yesterday and today and in the first day. No one takes into account that an engineer can also be a she. And I think we also have to consider that we include all those people who work in the construction business who have been excluded so far. I can understand that point, Boudewijn, because you've got a lot of experiences, and the people who are represented here are mostly those that come from that network that exists in an existing environment. But if we really want to be sustainable, we have to include everyone to this decision, particularly those young people who will be mostly affected by those things we're doing today. So sustainability requires to work hand in hand, to work together, to work in a team about all the disciplines that exist. And this also makes it required that we give up on privileges that we probably have today. So maybe I want to be the only profiter of a technology today. Maybe I want to stay within my own group of people. I don't want to share my knowledge with others. Maybe I just want to have the most sexy marketing, and other products should look odd against mine. Maybe I want to be the owner of the only truth. Or maybe I want to have the power to judge about the technologies and the actions of others. But I think that is not the right approach. So today we talk a lot about standards, and all those initiatives we take require that we install more institutions, more standards. But I believe that a standard is required to boost the technology, but there is a level of standardization where technology is limited. And if we really want to go into a certain where they say if the standard is getting too fragmented, all of a sudden it's getting too complicated and no one knows how to act. And that is our biggest problem. If we really want to go into a sustainable future, we have to find a way how we can condense our existing standards to the most fundamental values that are required to become sustainable. And those standard issues, all those items of standards which are on stakeholder interests, and individual vanity and other aspects and so on, they have to be completely deleted so that we come back to a very, very minimum standard that requires to adhere only to very simple but globally valid rules. And I think that is the biggest challenge that we have. Yeah. And here, I believe, to catch up on what Michael said before, I believe that the globe consensus could be a good starting point to find those fundamental, globally valid values related to sustainability. And then we still have to act locally, but we have those common ground values which are valid all over the world. And I think that's a step into the future.
Johan, you permit me to comment very briefly on what Wolfram said. First of all, we have a extremely strong lady sitting beside me who is very new in the concrete. How long have you been involved in this concrete thing?
4 years.
4 years, okay. Is that okay? So
no, but I understand the point made. It's important to both include all the bright new young people that come up with other ideas and to mobilize this initiative as a world initiative instead of a local initiative. But I continue to do the local work because that is also a task to be done.
The second thing is I want to underline is, could you mention this, Johan? This manual, my dream is that it becomes your manual, okay? So I really invite you to comment on it. After this session is over, we will include all the things we have learned, and I'll send it again to you and say, what do you think? And let's move on with this. Please, and on the standards, Wolfram, I should tell everybody, the EN 197 for cement took 27 years with 17 countries to be established, okay? 27 years they talked. And the EN 206, after 20 years talking, they could not come to an agreement. So everybody has their own little standard, has nothing to do with technology and everything with market position. And if we don't make this concrete economy healthy, we won't get anywhere, in my opinion. And that means the customer is in charge because the customer has the money, and the customer can say, I need this and this company to help me out because I don't understand the water binder ratio of this whole thing. Okay, and neither do the concrete technologies people understand it. There is only one, for me, there would be only one guideline for mixed design, and that is the water powder ratio. And then you see what you get. We have made incredible big steps in the refractory concrete, because if we wanted to put in a micronized dog shit, that was our thing, because we were delivering performance. And if we are sticking in this prescriptive thing, we won't get anywhere anymore. So let's please, I'm telling the European Commission, lead, follow, or get out of our way. That's what General Patton said. Okay, right now they have to get out of our way with EN 206. The person who made the mistake, he is retired in Spain. But he confessed as a good Catholic to me, and I gave him the blessing. But he has not done his, what do you call aflaat, Johan? What is it? So, I don't think we are running out of time. I think we probably we were losing people, but we will send. Is it too late right now? Dav, can we show quickly my last presentation? I will race through it. I don't know if you have it. Okay, this is no joke. We are emitting 7.1 billion tons of CO2 if you add everything together. It's not 8% because of the cement industry. No, the whole concrete industry is doing 7.1 billion tons. Next. Okay, just a race through this one. We have a value chain. Okay, contractor, subcontractor, and so on, and so on, and so on. The sub-supplier tells us how to work. That's the cement and aggregate producer. And they are trapped in the hole they dug themselves. A friend of mine from Lafarge, I have friends at Lafarge, he said, we can't get out of the hole we created ourselves, please help, okay? I'm helping them. We have a ladder, okay? The standards, the lobby, ECTP, Johan, we know each other from the ECTP. That was kidnapped in the conference in Amsterdam by Lafarge and by Heidelberg, who had the speaking time. We were all told to shut up. You know, so it's completely kidnapped again. So next, please. This is what we have to do. The client is on top. We will empower the client. We'll tell them what to look for. And the first day was excellent. We have the tools, we have the competence, and if they don't have the competence, they will go to the designers. And they should have the competence. They don't know, they don't have it at the moment because we do not give them the information they need. And then the authorities have to know what to bless. Stay there, please. And the suppliers, of course, if I can supply a lot, I'm not going to reduce my business. It's not coming from inside. No, and this is my point, education. I really will challenge you to think with me about how to do the education, bottom up, because 50% is on the problems are on the job side. We have to take care of that. And so next, please. We have the position of the verification. There's no excuse to be intimidated by certification. Okay, you have a self-declaration, and we can back you up with people like Tom van Beek and with the same spirit. Next, please. Okay, this is a famous formula. The organizations have to know we cannot take this without changing it, because technological innovation without system and process innovation is pure waste. When I came to Lafarge in 84, I discovered 2 patents of low cement concrete. They were not being used because the system was not able to take it. Okay, so we changed the system. Next, please. I think that is it. Okay, what is next? Please think about that. What shall we do? I hope people can stay a little bit on, but otherwise we'll discuss by email. But maybe you can show the paperboard right now. Again, if you finish this one, okay.
You can ask them to put it on the chat.
Daf, can you take it off and show where I am? Where am I based? I don't see myself anymore, which is maybe very good. Oh no, yes, I know what I did wrong. Here I am. Again, I was not supposed to touch this. Okay. I would say à table. Okay, everybody understands that. Let's sit down. Let the German-speaking people with a small group get together, and let's. I'm extremely happy, by the way, about the 3 Austrian musketeers. Okay, and with Wolfram, who has left his country already a while ago. I've worked for 2 German companies. I know how they think and do. Let's sit down at the table, okay? We challenge. We do the same thing, Johan, with Vlaanderen and the Netherlands, and so on. Let's sit down. So from the cultural point of view, we get together, and let's get together on the disciplines, the different disciplines, including the education. But the structural engineers, they have to be empowered, and they should have fun in their work, and they should know, they should go to the customer and say, I have good news for you, customer. I'm more expensive than the other structural engineer. But by spending so much more hours, I will save you lots of material, lots of CO2, and you will have a cheaper structure. Okay, so lots of work to do. I don't know in which form we'll talk about that. I have some dreams on that. I hope to share with you very soon. Johan?
Well, I was. It was a very nice afternoon on discussing Boudewijn. I looked to the number of participants, and I learned from some colleagues before in the running sessions that you should always stop a session on a high point. So we are really on a high point now, and I'm a little bit afraid if we continue that we will go down and see people dropping away. So my proposal is that we had very good sessions. We congratulate you, Boudewijn, by all the things you have been doing and kicking loose on having this session. I should say also that in the beginning I was rather a little bit reluctant if this would be working, but you made a good success of that. And I think you have your manual. It's a big step that you say, come on with comments and let's try to have this manual on a higher level. But I think it would be nice that after the session we have some specific discussion with Michael, with Wolfram, with Jacqueline on what's the way further. And if I could, I would email or send you a drink, which is not possible, of course, but I hope that you have your glass or wine of beer next to you. And I would like to say, let's close the session and let's come back when we have this dripped down